Hello everyone, and welcome back to my channel Scribbles in Bioinformatics. And in this video, let us continue with our Gromacs simulation. In my previous video, I dealt with how is that you perform energy minimization, and in this video we would edit a few files, make a few files called as index files, and I will tell you how is that you initiate the equilibration simulation. Okay, so without any further ado, let us dive into what we are supposed to do. Okay, now before we start the equilibration process, it is necessary that you should have some index files ready. So let me tell you what are the index files and what is the fuss all about. Basically, index groups are necessary for almost every Gromacs program. Here, in our case, we need to do some special indexing for the ligand group in our system, right? And we would be using Gromacs make index command for creating the index files as such. So first, we will have to create index for our ligand, and for creating the index for your ligand, here is the command that you are supposed to be copying over here. Simply select it, copy it, and let us continue with the same Gromacs command prompt that we have used for energy minimization, right? Okay, so simply paste what it is there. Okay, let me tell you that this gmx will activate Gromacs in the background. Make ndx is the command that is used for creating the index for the input file called as leak.grow, and for output it will create the file called as index underscore leak.ndx that will keep all the information, indexing information for the ligand. Okay, this is what it is. And once you hit enter, now it is asking you some things, right? So it is kind of asking you how is that you would be splitting your groups, right? So what we will be doing is that this is what we are supposed to select. Okay, now if you are typing, make sure that you type exactly as I have copied over here: 0 and this group exclamatory mark, then small a, h, and star. So running this command offers the menu for indexing. So what we have done is that we are trying to index this thing. After completion, the Gromacs and just hit enter now. Okay, and once the command is complete, you are supposed to press this Q and hit enter, and your indexing will be done. So hitting Q terminates this command, and whatever this thing that we have added is the information that is required for indexing your ligand. Okay, so once this command is completed, again if I sort by date modified, then you can see that index underscore leak dot ndx file has been created. So this index file, this file keeps tab on the ligand's index information. Well, generally, when you create a new index, you also have to have a file that contains a list of atom numbers and 3 force constant for x, y, and z direction. Now, to update these force constants, we generally use the gen restr command from Gromacs. Okay, so let us now update the force constants, and for doing so we have this gen Gromacs gen rest command, right? All I have to do is to copy this thing. I'm not going into more details of what these commands are. Maybe I will create another video that deals with this thing. So current interest of today's topic is to get you familiarized with how is that Gromacs on window is to be used. Okay, so here is the thing that you would require to run the Gromacs genrester command. Okay, just hit enter. Okay, now it is offering you with a menu wherein you are supposed to select any group. So over here, what we have done is that selecting this group 3 enables the selection of all the atoms used in the indexing. This command will create a single ITP file called as position restrain ligand ITP file. This position restrain ligand ITP file will contain a list of atom numbers and the 3-4 constants for the X, Y, and Z direction. So let us move ahead with selecting group 3 and hit enter. Okay. So now my friends, let us see that if the so-called ligand position restraint file has been generated. Yes, you can see that the new file has been successfully generated. Well, now we have got the index of ligand as well as the ITP file of our ligand with all the force constant of information that is required. Well, now we need to incorporate this information in our topology files now, right? Because we have done it separately and our main topology file don't have any of the idea of the indexing thing that we have done. So we need to first update our topology file that is there in form of this topol.top. Okay, so you can now open this topol.top file in any text editor. Okay, and once you open it, you need to go to the very end. Now you can see that initially we begin with only protein molecule, then we have manually added the information of ligand, then we solvated it, added this much amount of water molecule, and when we charge neutralize our system, this much Na ions were added and this much chloride ions were added, and over here we don't have any information of our ligand index now. Okay, so at the very end of the document there is a section that holds the information like include position restraint file. Okay, this is what I am talking about, include position restraint file. For time being it contains only position restraint data on the protein molecule. We are supposed to now add the position restraint data for our ligand. Copy this text and simply paste it over here. Okay, it is not necessary to have the space over here. You can keep it like that, no issues with it. I will simply include this thing. Okay, so now my friends, what we have done, let me save this thing. Always keep this habit of saving the intermediate work. So now once we have added these few lines, now we need to make one final index file that contains all the change information we have made so far for running subsequent equilibration simulation, right? Okay, this is what we will be doing. Okay, now what we will do is that we would be again using this Gromacs make index command for merging all index for protein as well as ligand. Okay, it will now create a new file called as index.ndx. Okay, so once you copied it, pasted it, just hit enter. Okay, now it is asking you, running this command, it has kind of offered a menu for selecting groups to be involved in final indexing. So group number 1 is the protein that contains 5050 atoms. We have already indexed it in position restraint file. And now group number 13, ligand, it contains 33 atoms. So what we will be doing is that we will use this thing. I will simply copy it and paste it over here. This one tells that you need to merge index for protein with this. This is the pipe symbol. Make sure that you use the pipe symbol on your keyboard, and 13 correspond to your ligand. Okay, so the pipe here is used for merging the protein and ligand groups. Once you hit enter, then by hitting this Q, pressing this Q and hitting this enter will complete the command. Okay, now my friends, you can see that new index file has been generated, that is called as index.ndx. Okay, now everything is in place, and thus we are ready to proceed for our equilibration simulation. Okay, now for before we proceed further, now there is scope for you to configure your equilibration simulation, right? To configure, what you can do is that you can edit this MDP files as per your requirement, right? So first we will be doing equilibration simulation in NVT ensemble. So for that, make sure that you have this nvt.mdp file in the working directory, right? So once you make sure that there is MDP file, you can edit this MDP file as per your requirement. You can change groups, you can do whatever you wish. Okay, so for the sake of simplicity, well, let us not change anything. Let us proceed with whatever simulation parameters that are there in the MDP file. Our objective is just to demonstrate how is that you use this Gromacs in Windows operating system. I have copied it, I am pasting it over here. This Gromacs GromPP will create a TPR file for NVT equilibration. Just hit enter. Now you can see that a new nvt.tpr file has been created, and thus my friend, you are ready to run the equilibration simulation in NVT ensemble. We would be using mdrun command. Simply copy this command and paste it over here and hit enter. That's it, my friends. The second command that we have initiated, Gromacs mdrun. The second command, it first build the TPR file for NVT simulation, and this mdrun command will actually run the MD simulation for 100 picoseconds. So in background, the simulation is running. Let us wait and be patient. It might take 10 or 20 minutes. So I will stop my recording, and later on, after the simulation is over, I will tell you what are the output files that are generated. So let us pause our recording for a while till the simulation is over. Okay, the simulation is over now. As you can see, once the simulation is finished, it will show you the final performance of the simulation, like how much time it took, and what was the performance like. In the current simulation that we have run, it took like 2.669 hours per nanosecond, right? So in this way, the simulation in NVT ensemble is over, my friends. In our next video, I will tell you how is that you initiate the NPT ensemble equilibration simulation, and we would then conduct the final production run. So till now, keep simulating.